Welcome to this Forge College Explainer. I am so thrilled to have you here today because honestly, we're going to do something incredibly satisfying. We are building directly on our previous lesson, which was all about initializing and setting up a Solana program template. Think of that last step as pouring the foundation and framing out the walls of a digital house. But, a house isn't very useful if you can't interact with it, right? So today, we are going to customize that template. We're going to take a super safe, focused approach and wire up a simple doorbell to our newly built digital house. It's light, it's fun, but it is absolutely foundational to understanding how Solana programs actually operate under the hood. Okay, let's dive into this. Here is the engineering blueprint for today's lesson. We'll start with the scaffold blueprint, map out the key files, wire up the ping instruction, build the handler, route the dispatch, and finally do some inspection and testing. All right, section 1, the scaffold blueprint. Before we start blindly pulling wires out of the walls, let's establish exactly what we are trying to accomplish. The crucial concept here is a project increment. When you're working with templates, the absolute worst thing you can do is change 50 things at once, hit compile, and just watch your terminal light up with a wall of red error messages. We've all been there. Instead, we're going to implement a minimal viable modification. In our case, a simple ping instruction. It doesn't move funds, it doesn't alter complex token states, it just safely proves that we understand how the template pieces fit together. We apply a verifiable edit to a known good baseline. It keeps the risk super low, and more importantly, it keeps our sanity intact. Moving right along to section 2, mapping the key files. To make this project increment a reality, we need to know precisely which electrical boxes we'll be opening up. This is our battle plan. We've got 4 main files we are looking at. First, our instruction.rs file. This is where we define the instruction enum, which is basically the physical doorbell button itself. Second, the processor.rs file holds the handlers and dispatch. Think of this as the chime inside the house that actually makes the noise. Third, our lib.rs file exposes our public API. We rarely need to mess with it for simple increments, but we keep an eye on it. And lastly, test/pingtest.ss is our testing ground. Knowing exactly where to go means we'll never get lost in the codebase. Which brings us to section 3, wiring the ping instruction. Let's actually define that button. Adding literally any feature to a Solana program follows these 4 exact steps. It is the fundamental circuit path. You edit the enum, implement the handler, register the dispatch, and write a test. Memorize this loop, guys. It will save you so much headache down the road. So let's tackle step 1. Over in our instruction.rs file, we are simply adding the ping variant to our myInstruction enum. You might see some unpacking helpers there using serialization like borscht, but don't let that technical jargon scare you. By adding this one variant, we've essentially wired the physical button that users can press. We're just telling the program, hey, here is the exact format of a message you are allowed to receive. It's simple, it's elegant, and it's perfectly structured. Section 4, building the processor handler. Who actually answers the door when the button gets pressed? Now, I want you to burn this mantra into your brain. If you remember only one single thing from this entire explainer, let it be this golden rule. Change the enum, implement the handler, register the dispatch. Seriously, say it with me while you code. It guarantees your runtime routing actually works. And here is our handler in action inside the processor.rs file. We write a new function called processPing. And honestly, I love this part because this function is the ultimate Slacker feature. It does absolutely nothing to the program state. It just checks to make sure the inputs aren't completely broken, and then it returns a simple OK success message. Why? Because right now, we don't need it to solve complex math. We just want to prove the wiring works. It just says, hey, I heard the doorbell, everything is fine. It's a massive confidence booster. Next up, section 5, routing and dispatch logic. We have the button outside, and we have our Slacker chime on the inside, but we still need to connect them at the main switchboard. Think of the match statement in your processor file as a giant switchboard operator. Initially, the operator has no idea what ping is, so the signal just drops into the void. But if we add a new routing branch, we are basically telling the switchboard, hey, when the ping instruction comes in, please route that signal directly to our processPing handler. Boom, circuit complete. The program now knows exactly what to do. Almost done. Section 6, inspection and testing. The universal dread for developers everywhere. You make a change to a pristine template, you stare at the screen, and you're frankly terrified to hit compile. This is exactly why we never just guess and hope. We absolutely must test our work locally before we even think about deploying it. So we write a minimal local test inside tests/ping test.rs. Using the Solana program test harness, we write code that artificially pushes that ping button. It constructs the instruction and fires it off, verifying that the entire path executes perfectly without panicking. It's literally like building a little robot to push the doorbell 100 times just to make absolutely sure it rings every single time. Here is our final checklist. If you can check off these 3 strict engineering criteria, you are golden. Number 1, the scaffold compilation passes without errors. Number 2, the dispatch match explicitly includes your new ping branch. Number 3, your test suite executes and passes. If you've got these 3 things, congratulations! Your project increment is completely valid, seamlessly integrated, and you have officially customized a Solana program template. You guys did incredible work today. We took a blank slate and safely wired up our very first interactive feature. As you prepare for our next lesson, where we'll learn how to submit this pristine code for a pull request review, I highly encourage you to visit forge.college to dive even deeper into Solana and other Web3 topics. As a fun challenge before you move on, ask yourself, what other simple, harmless instructions could you wire up right now to test the limits of your new template? Keep exploring, keep building, and I will see you in the next explainer.